This video shows how to create a self-signed certificate for use by Zowe that will be held in a RACF keyring. Open the JCL member ZWEKRING in the SAMP lib created when you install Zowe. For this video, I'll be using the Zowe Explorer. The JCL member can be configured to work for 3 scenarios. Option 1. This is a top-down scenario to generate a new certificate authority and use this to sign a newly generated certificate. Option 2. Configure Zowe to work with an existing certificate already held in the RACF database. This is a bottom-up scenario to configure Zowe to reuse the existing certificate already configured on ZOS. Option 3. Configure Zowe to work with an existing certificate held in the PKCS12 format in a dataset. This is a bottom-up scenario, reusing a certificate that may have been externally created off-platform by a trusted signing authority. For this video, we're using the top-down self-signed certificate, so leave the JCL variable option equals 1. The Zowe team who wrote this JCL member are based in Prague, Czech Republic, so the defaults reflect their home base. I'm going to change the city, province and country for the certificate authority to my hometown of Hursley in Hampshire in the United Kingdom. The certificate we're creating needs to include the network addresses that we'll be using for Zowe's transport layer. Update these to be your hostname and IP address. Submit the ZWEKRING JCL member to run as a batch job. It's a good idea to check the steps to make sure everything ran as expected. Run RACF, run opt1, as we were generating top-down option 1, and also comRACF will show us the results of all of the commands the JCL issued. From the Zowe Explorer, it's also possible to issue TSO commands to look at the artifacts created. RAC dsert listring shows us the contents of Zowe keyring owned by Zowe's functional ID ZWESVUSR. This contains our certificate authority and our 2 certificates, localhost and JWT secret. We can look at these in more detail. RAC dsert list cert auth for local CA shows us certificate authority, and we can see it was signed in Hampshire in the United Kingdom. RAC dsert list localhost shows us the certificate itself, which will include the hostname, the IP address, and also details of the signing authority that we used. The second certificate, JWT secret, should look similar to our local host. Having created the cert authority local CA and the 2 certificates localhost and JWT secret and connecting them all to the newly created Zowe keystore, the next step is to configure our Zowe instance to use them at startup. This is done by creating a USS keyring directory that will act as a proxy for the RACF certificates. The Zowe runtime bin directory contains a file zoe-setup-keyring certificates.env. Open this in an editor. Verify_certificate controls whether Zowe will check the signing authority of certificates presented to it in order to trust their provenance. On the LPAR we're starting Zowe, the ZOSMF certificate is self-signed, so we need to override verified certificates to be false. If your ZOSMF certificate is signed by a trusted authority, or if you're intending to import its certificate into Zowe's trust store, you can leave verified certificates as true. The verified certificates parameter affects not just ZOSMF, but all API services that present certificates to the API gateway. One scenario that occurs with certificates is that even though they're signed by a trusted authority, the network address they're being used for doesn't match the IP address they're assigned for. For example, a trusted certificate for address a.b.c.d is used for the address a.b.c.e. The correct fix for this is to have a.b.c.e added as a subject alternate name or SAN to the original certificate. The parameter noStrict_verify_certificates can be set to false. This tells Zowe to not check that the network address being used to present a certificate is one of the ones the certificate is signed for. On our LPAR, our ZOSMF certificate was signed for a different IP address, so we'll set this value to false to avoid runtime errors. Having relaxed all of Zowe's certificate trust checking, the next step is to define the USS directory we wish our proxy keystore to be generated into. We'll be creating one called Zowe-keystore in my home directory. Open a USS terminal. For this video, I'm going to SSH into Unix System Services. To generate the keystore directory, execute the script zoe-setup-certificate.sh from the Zowe runtime-bin directory. To tell the script to use the Zowe-setup-keyring-certificate.env file we edited earlier, set this as the value to the script's -p parameter. The script creates the keyring directory by reading the certificates.env file. In our case, home directory /Zowe-keyring. Let's take a look inside this directory using the Zowe Explorer. Because the certificate authority and the certificates themselves are held in the RACF keyring, the local _CA and local host directories within the keystore directory are actually empty. By comparison, another keystore directory, Zowe-keystore, was generated earlier by myself to contain the certificate authority and the keys themselves. The location of the keystore directory used by a Zowe instance is held within the instance.env file's keystore_directory property. Let's set this to be the newly generated keystore, home directory /Zowe-keyring. Now we're all set to launch Zowe. Do this by navigating to the Zowe instance directory itself, and within the bin directory, running the script zoe-start.sh. This will echo to us the name of the started task, which in our case is ZWEJ1SV. We can monitor Zowe's startup progress within the Zowe Explorer by setting a filter for ZWEJ*. The first thing to do is to keep an eye on standard error and make sure that nothing is written here. Then check standard out to make sure that all of the services start up correctly. A good way to check when Zowe has finished starting is to look for the message ZWEAM000I. There should be 4 of these, one for each of API mediation layers services. Also, ensure the message ZWED0021 has been successfully written to the standard out log. Now, we're ready to actually test Zowe. Open a web browser and navigate to the Zowe host name and port 7554 for the API mediation layer. Because we generated our own certificate authority and used this to self-sign Zowe certificate, the browser doesn't trust this and will challenge us to make sure we're okay before proceeding. Let's use the browser to make sure why it didn't trust Zowe certificate. In our case, we can see it's because the certificate authority was signed in Hursley, Hampshire, UK. This, however, was the same certificate authority we generated earlier using the ZWEKRING JCL, so all is good. Select API Catalog and make sure we're successfully able to log on using our TSO user ID and password. Another good smoke test is to try and reach the Zowe desktop. This is done using the gateway port 7554 and the URL ui/v1/zlux. Make sure we can log into the desktop using our TSO user ID and password again, and also try out some of its applications, such as the file editor, to work with USS files, datasets, and it's also a good idea to try some of the other apps, such as the 3270 emulator, or in our case, the ZWEKRING.